In this video, I will show you how to derive the energy equation for a closed system. Suppose I have a typical closed system of a piston cylinder device here. The system I'm referring to is actually the fluid contained in the cylinder. Initially, the total energy of the system is U1 plus KE1 plus PE1. There are basically two types of energy here. Internal energy, which is U, and mechanical energy, which is Ke plus Pe, kinetic plus potential energy. If I let the system go through a non-flow process, let's say if I heat up the system, and it causes the fluid to expand, the piston moves up. In this process, there's heating taking place. Heat is added to the system, and it causes the energy of the system to increase. So I add Q to the equation. And there's also working taking place here because the fluid pushes the piston, and the system does work on the surroundings, which reduces the energy of the system. So I have to minus W here. So there are two means of exchanging energy here, by heating and by working. In fact, heating and working are the only two means of exchanging energy for closed systems. There's no other means. So this whole thing will be equal to the final energy of the system. The final energy of the system will be denoted by U2 plus Ke2 plus Pe2. And this will be the energy balance equation for a closed system. Let's simplify the equation a little bit. For closed systems, we usually don't consider change in Ke and Pe because we assume that the system is in a fixed position during the process. This assumption is reasonable for most situations associated with closed systems. So we're going to remove all the Ke and the Pe terms from the equation. After rearranging the terms, we will get this equation. And this is already the energy equation for a closed system. It is the mathematical form of the first law of thermodynamics applied to a closed system. And this equation is usually written in another form. Here, we simply replace U2 minus U1 with delta U. So remember that delta U is always the final internal energy minus the initial internal energy. We have just derived the energy equation for closed systems, which is Q minus W equals delta U. This equation is also called the non-flow energy equation, abbreviated as Nfee. Here Q means heat input, W is work output, delta U is change in internal energy. This equation simply means that energy exchange by means of heating and working would cause the internal energy of the system to change. Sometimes it's more convenient to consider energy on a unit mass basis. In this case, we need to divide this equation throughout by mass. Then we will get another form of the Nfee. So in this form, all the symbols are lowercase. Lowercase q is heat transferred per kg. W is work done per kg, and delta U is change in specific internal energy. So in situations when energy is considered for a unit mass, then we should use the equation below.